going to start our volumes of revolution notes, and what that pretty much is anything that's, I guess, round in shape, like circular in shape, we can actually find the volume of by rotating a two-dimensional kind of surface around an axis. And so if you can see kind of what I have here, this is a two-dimensional light blue surface. If I revolve it around the x-axis, say, we will create what's called a volume, right? And we are doing this by a technique called disks. And so if you look over here, this circle is completely filled in, and this volume is completely filled in. So it's like the nose cone of a plane or a missile, or maybe like if you really zoomed in on a tip of a pencil or a marker. Okay, that's kind of what this is, and we can use our math to be able to calculate the volume, space that this would take up. Okay, you could do something very similar to anything that's round. So like even this little boba, right? You could see like this little boba has kind of a circular, what we kind of like little cross section. So I could take maybe some kind of like trapezoid, revolve it around an axis, and I'll get be able to calculate the volume of something like this. Um, so so this right here, because it makes a complete circle, is called a disk. Okay. Let's reset this. Now, if I revolve, okay, if I revolve around a line like this, and this is the shaded area I want to revolve, you guys will see that there's a gap here, right? And so when I revolve this around, you're gonna see something like um, a gap appear, kind of like if you had to guess what shape it is, what do you think it might be? It'd probably be, in this case, it's going to be a cylinder. And so if I revolve this, okay, you can kind of see that empty white space inside. And so this will be similar to a disc, but if you notice the sections here, they're not completely filled in circles. It's a circle with another circle cut out of it. And so this hollow center is a cylinder. Okay, this hollow center is a cylinder, and that's kind of the volume that's not included in this. And so the way we actually figure this out mathematically is we find the volume of this thing completely filled in, and then we take away the volume of that cylinder. Okay, algebraically using calculus, right? We're going to take this circle completely filled in, find the area of this empty circle, and then subtract the two. And then when we integrate, then we'll have the complete volume all the way across. Okay, so right, we're going to add up all of these little hollow circles together to make the volume. Okay, all right, so let's kind of get into this using our notes. So let's move this up here. Okay, so we're going to take a similar example that we just did, right? We're going to kind of fill this part out. Ultimately, we want to find the volume of this, right, of this cone. And so what we're going to do is we're going to mathematically find the area of this thing, right, and then rotate that around the x-axis. Okay, so this would be, say, the x-axis. This right here would be x equals 4. And then this right here would be that shape I just put up there. And when I revolve it around the x-axis, we're going to get this whole filled in kind of like nose cone-like shape. Okay, we'll get more into the math part in the next page of notes.